Hi dear viewers, in this video I will give you a brief idea about the impact of the gain on system responses. Let me take one second order system h of s, which is normally being described with omega n square s square plus 2 zeta omega n s plus omega n square. So this is a system. If I take the step response of the system, I will get the plot. And what is the impact when I add one gain to the system? So let us take the k is a gain. When I multiply the k with h of s, what is the impact of this k, the gain, on the system response? This is I am going to demonstrate this video, and stay tuned, watch. So before that, don't forget to subscribe my channel. Let me take you to the MATLAB. A transfer function model is created. So omega is 10 and theta is represented with z. Is underdamping system, and here goes h of s, which is omega by s square plus 2 zeta omega times s, then omega square. So h of is a second order system, and this is omega square. Now I'm going to take the step, going to plot the step response of h. So here you can see that this is the step response of that given second order system. And now along with that, I'm just fetching some information of time response, details of the system. Here you can see that the rise time is 0.2127 and settling time is 0.59, and overshoot, the peak time is happened at 0.4408, and so these are the step response of the system. So now I just introduce one gain, its value is 10, and then I am going to plot the gain that is multiplied with the system h, and see that the changes. So earlier we can see that the steady state value of that response is 1, but here the steady state value is increased to 10 because the value of gain is 10. Now if you check the step response of this system, so when I introduce a gain, you can see that there are some changes, but the changes is happened in the settling max and settling minimum and the peak. But except these three data, there is no changing in the system responses. The rise time is same, and the settling time is same, and the peak time is also same. That means that the k has not changed the system responses. The k, by introducing the value of gain, by introducing the gain is just modified the amplitude of the response. So I'll bring you the comparison of these two responses in a single. So this is the system responses of a function h, omega n square s square 2 zeta omega n plus omega n square. Here this is k times h of s, so this become k omega n square s square to theta omega n s plus omega n square. So let us check. See, the rise time is 0.2127, but in the rise time in the second case it's the same. The settling time is both the case same, and the peak time is also same. So by adding this, the k, the impact is exactly, it comes here, these two parameters. See that the settling minimum, the minimum value is here, it is 0.9, that is multiplied 10 times, so it becomes 9.0010 in the second case. And also settling max, the previous case settling mass was 1.04, but here the 1.04 is, it's multiplied with the 10, so it becomes 10.45 in the second case. And also, so we can see that the peak value, the first case without gain, the system produced a peak of 1.04, but in the second case the peak is 10.4599. But if you see that these three parameters, the rise time, the settling time, and the peak time, is not changed with the introduction of k, the gain. So the gain has changed only this, the peak values. So earlier it was 1, here it is k. So because here by default it is 1, so k is 1 here, but here the k is 10. So that is the only changes the k bring to the system responses. So adding k never going to change the system characteristics. So we will learn more about how to modify the system characteristics with the addition of zeros and poles in the next video. To watch my upcoming videos, subscribe my channel, as well share with the similar minds. Thank you.